Institute of Engineering and Technology. Today we are going to study a very important topic of vector calculus, that is Green's theorem. Green's theorem in the plane. If mxy, nxy and their partial derivative del m by del y, del n by del x are continuous in some region R of xy plane bounded by a closed curve C, then closed integration over C m dx plus n dy is equal to double integration over R del n by del x minus del m by del y dx dy. So this is the statement of a Green's theorem. Okay. Now let's solve an example. Verify Green's theorem in the plane. Integration is given 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the boundary of the region bounded by x equal to 0, y equal to 0 and x plus y is equal to 1. Okay. Now let's state the Green's theorem. What it says that closed integration over C m dx plus n dy is equal to what? Double integration over region R del n by del x minus del m by del y dx dy. Okay, so whenever it is asked that we have to verify Green's theorem, so what we have to do? We have to find this LHS and RHS both and to see that both the answers are same. Okay, so let's begin with the RHS. Okay, so firstly we will solve this. Now before solving this, what we'll do, we'll draw the region. Okay, now x is equal to 0 is given. Okay, firstly, so this is your x-axis. Okay, this is y-axis, right? So this is your x is equal to 0, this is y is equal to 0. All right, and this is the line x plus y is equal to 1. Give the name O, A and B. Okay, now we have to find line integral over C m dx plus n dy. Okay, so what we will do, we will follow a path. Okay, we will find integration over OA, then we will find integration over AB and then over BO. Okay, and then we will add them, so we will get this total integration. Okay, so integration, closed integration over C m dx plus n dy is what? It is integration over OA m dx plus n dy plus integration over AB m dx plus n dy and at last integration over BO m dx plus n dy. Okay, so now we will solve all the three and then we will add them. Okay, so now let's begin with this integration. Okay, so firstly along OA. Now I'll again draw this graph over here. Okay, this is x plus y is equal to 1. Okay, this is x is equal to 0, this is y is equal to 0. All right, we have to give this name OAB. Okay, so along OA, so along OA, so this is y is equal to 0. Okay, so we have y is equal to 0, so dy will be equal to 0. Okay, now if we want to give the points, okay, so this is 0 comma 0. Okay, this is 1 comma 0 and this is 0 comma 1. Now dy is equal to 0, so you can see that this x component, it varies from 0 to 1. Okay, so x varies from 0 to 1. Okay, so integration over OA m dx plus n dy is equal to what? Integration from 0 to 1. This is your m, this is your n. Okay, so 3x square. Okay, now in place of y we have to substitute 0. Okay, so this is 0 dx as it is plus, now in place of y again we have to substitute 0, so this is 0 minus, again here we have y, so this is also 0 and here we have dy, so this is 0. Okay, so we have only this integration 0 to 1 3x square, right? Just integrate this, so it will give you 3x cube upon 3 and the limits are 0 to 1. Okay, this 3 will get cancelled, so your final answer is what? 1. Okay, now along this AB, okay, we'll find along this AB. Now AB is what? x plus y is equal to 1. So we can say that y is equal to 1 minus x. So dy is what? Minus dx. Now here we are converting everything in the form of x. Okay, so again we have to take the limit of x only. Okay, so we can say that x varies from, okay, here x component is 1 and x goes to 0. So x varies from 1 to 0. Okay, so this integration over ab m dx plus n dy, okay, it will give you integration 1 to 0, right? Now 3x square as it is minus 8 into y square. Okay, so in place of y we will write 1 minus x whole square. All right, this dx plus now 4 into 1 minus x minus 6x into 1 minus x. In place of dy we have to write minus dx. Okay, now let's simplify this. So what you will get here? Integration 1 to 0. Okay, now here 3x square minus 8 into 1 minus x whole square, okay, plus 4 into 1 minus x as it is, plus now now if you will multiply minus over here, okay, so we have minus over here, so you will get minus at this place, okay, and this minus minus will become plus, and multiply 6x inside, so we'll get 6x, okay, minus 6x square. This minus and this minus will become plus, so 6x minus 6x square dx. All right, now we have to integrate this. So integration of 3x square is what? X cube upon 3. 3 will get cancelled. So we have only x cube minus 8. 1 minus x whole raised to 3 upon minus 3, because here the coefficient of x is minus 1. Alright. Now minus 4. Here 1 minus x whole square upon minus 2 from this. Okay. Plus now here we'll get 6 x square upon 2, so it will give you 3x square, okay, and from here we'll get 6x cube upon 3, so it will give you 2x cube, and the limits are from 1 to 0. All right, now substitute the limit. Okay, so first substitute the upper limit, so this term is gone, okay, minus minus plus, so this is 8 upon 3. If you will substitute 0 over here, we'll get only 1. Now again this minus minus will become plus, so it will give you 2. These two terms are gone, right? Minus, now if you will substitute 1 over here, we'll get 1 here. 1 minus 1 is 0. This term is also 0. From here we'll get 3. From here we'll get 2. Okay, just simplify this. Okay, so this is 8 by 3 plus 2. Now this is 4 minus 2, so it will give you 2, and here we have minus 2. Simplify, so your final answer is what? 8 by 3 over the line AB. Clear? Now let's solve along BO. Okay, so this is x plus y is equal to 1, this is y is equal to 0, x is equal to 0, OAB. We have already solved OAAB. Now it's time to solve BO. Okay, so along BO. Now BO is which line? X is equal to 0. Okay, so your dx will be equal to 0, and y varies from what? And y varies from, okay, just write down the points. So this is 0 comma 0, 1 comma 0, and 0 comma 1. Now y varies from 1 to 0. Okay, so y varies from 1 to 0. Integration over BO m dx plus n dy is equal to what? Integration from 1 to 0. Alright, now in place of x, now we have to substitute 0. So this term is 0. Here dx is 0. So this first term is 0. Okay, so this is 0. Plus now here in place of x substitute 0. So we have 4y. Okay, here substitute 0. So this term is gone. So we have only dy. Right? So 4y. Now integrate it. So 4y square by 2, limits from 1 to 0. Simplify this. Okay, so you will get 2, 0 minus 1. So your answer is what? Minus 2. Okay, now at last we have to find closed integration over C m dx plus n dy. Okay, so we have to add all the three answers, right? Now let's see, the first answer is what? 1. Second answer is 8 by 3. Okay, so 1 plus 8 by 3 minus 2. Simplify this. So 3 plus 8 minus 6 upon 3. Okay, so it will give you 5 by 3. So this is your LHS. Okay, so left hand side answer is what? 5 by 3. Now our next task is to find RHS. Okay, so what is RHS? RHS is double integration over R del n by del x minus del m by del y dx dy. Okay, so we have to solve this double integration. Now here m is what? M is 3x square minus 8y square. Okay, so we have to find del m by del y, means derivative of m with respect to y, keeping x as a constant. So this term is gone. So here we have minus 16y. Okay, n is what? N is 4y minus 6xy. Okay, so del n by del x is equal to what? This term is gone, minus 6y. Okay, now again let's draw the region. Okay, so this is x plus y is equal to 1, right? This is y is equal to 0 and this is x is equal to 0. Alright, now we have to solve the double integration. Okay, and this is the region of integration. So what we will do, either we can make a vertical strip or a horizontal strip. So let's make a vertical strip. Okay, now we can say that this vertical strip, okay, it starts from, this is vertical strip. All right, vertical strip starts from here, it starts from y is equal to 0. Okay, and it ends at this point. So this is line and ends at x plus y is equal to 1. Okay, so we will write limit of y first, right? So limit of y is from y is equal to 0, so y is equal to 1 minus x. Okay, and limit of x will be what? From x is equal to 0. Okay, now we know that this is 0 comma 0, 1 comma 0 and 0 comma 1. So x varies from 0 to 1. So limit of x is what? X is equal to 0 to x is equal to 1. Substitute the limit, so you will get 0 to 1 minus x, 0 to 1. Okay, now del n by del x, this is minus 6y. Okay, minus 6y minus minus, it will give you plus 16y. Okay, here dy dx. Clear? Now let's simplify this. So this is double integration 0 to 1, 0 to 1 minus x, 10y dy dx. Okay, now integrate this. Okay, so what you will get here, integration 0 to 1, 10 as it is, y square by 2, and the limits are what? From 0 to 1 minus x. Substitute the limits, take out 5 outside. Okay, 10 upon 2, it is 5. Integration 0 to 1, 1 minus x whole square dx. This is equal to 5. Integration is integrated, so 1 minus x raised to whole 3 upon minus cube. Correct, because the coefficient of x is minus 1 and the limits are from 0 to 1. So this is minus 5 by 3. Substitute the upper limit, so 1 minus 1, it will give you 0, minus substitute the lower limit, so it will give you 1. Simplify this, so your final answer is what? 5 by 3, and this is what? This is your RHS. Okay, now previously we have proved LHS is 5 by 3 and RHS is also 5 by 3. Okay, so therefore we can say that LHS is equal to RHS, and therefore Green's theorem is verified. Okay, so in this way we have to verify Green's theorem. Okay, so firstly I'll briefly discuss the method. Okay, what we have to do, first we have to find this closed integration over c m dx plus n dy. Okay, whatever the graph is given, we have to follow the path and we have to find this line integral. Okay, and then after using this double integration, okay, over region R, we have to find this, that is del n by del x minus del m by del y dx dy. Okay, and we have to check that both the answers are same or not. Okay, and whenever we are verifying the Green's theorem, you will get the same answer. Okay, so I hope you have understood throughout the session. Thank you for watching.